All right, so we're diving into Janus-Pro today. It's a multimodal model, and it's got some pretty bold claims about its performance, especially with both, image understanding and text-to-image generation. But the interesting thing here, it's really all about the structure of this model.
Yeah, you hit the nail on the head there. The thing is, Janus Pro really tackles a problem, a challenge that's been around in multimodal models for a long time. See, most models have always just used a single visual encoder for both understanding and generating images. But the team behind Janus Pro, DeepSeek AI, they decided to kind of flip that idea on its head.
So they're basically saying using one tool for two completely different jobs wasn't really the best approach.
Exactly. And they came up with this idea of decoupled visual encoding. So basically, they use separate encoders, one for understanding, one for generation. Think of it like, specialized tools, right? You wouldn't use a hammer to screw in a screw.
Yeah, it makes sense.
So for understanding, they use what's called a SIGLIP encoder, really good at extracting those deeper semantic features, the meaning from images. And then for generation, they use a VQ tokenizer, which basically you can think of it as turning the image into a language the model can work with.
Okay, that's pretty cool. But wouldn't having two different encoders just make the model more complex and harder to train?
Right. It's a good question. And to deal with that, they developed a very specific training strategy. Three stages, actually. So in the first stage, they train on ImageNet, that huge data set of labeled images, but they train for longer than usual. And this helps the model really grasp at the nuances of the image data.
So longer training in the first stage. What happens next?
Well, this is where it gets interesting. In the second stage, they drop ImageNet completely, gone. And they just focus on training with text to image data. So by taking ImageNet out of the picture, they can train the model much faster and more efficiently on, creating images from those descriptions.
Oh, so they're really streamlining the training by focusing on specific data sets at different stages. Clever. So what about the final stage then?
Stage three, all about fine tuning. They very carefully adjust the ratio of different data they're using to really balance those understanding and generation skills, making sure it can do both really well.
All right, so we've got these separate encoders, this multi-stage training process. What about the data itself? We're talking multimodal here, so it must be a lot more than just your average image set.
Yeah, it is. So for multimodal understanding, they really went all out, added a ton of samples, like 90 million, from all sorts of different data sets, image captions, data for understanding, like tables and charts, even documents. They even threw in some meme understanding and Chinese conversation data just to mix things up.
Wow, that's quite the mix. What about the image generation side? Do they stick to just real-world photos?
They did use real world images for sure, but they added something pretty interesting too, a massive amount of what they call synthetic aesthetic data, like 72 million samples of it.
Okay, now I'm really curious. What is synthetic aesthetic data? And what's so special about it?
Well, you see, by adding this synthetic data, they essentially taught the model to appreciate beauty. This helped the model learn quicker and actually produce images that were not only more stable, less likely to have errors, but also higher quality visually compared to models trained only on those real photos.
So they're training it not just to generate realistic images, but actually good-looking ones. That's fascinating. But before we get into how well it all works, let's talk about the different versions of Janus Pro, right?
Right. So they've got two main models they developed, Janus Pro 1B, that one's got a billion parameters, and then there's Janus Pro 7B, 7 billion parameters. And this scaling up is a big deal because it shows that this whole decoupled visual encoding thing, it's really flexible. It can handle a lot more information and potentially, even better results as the model size grows.
Okay, so we've got this model, unique architecture, complex training process, huge amounts of data. The big question now is how well does it actually perform?
All right, let's start with the multimodal understanding. They tested Janus Pro using Bench, which is a benchmark that basically tests how well a MADI can understand text and images together, like how well it can grasp the meaning of visual information when it's linked with language.
Right, so it's not just can it identify a dog in a picture, it's more about can it understand what that dog is doing and why it matters in the context of, the whole image and any text that goes with it.
Exactly. And the results. Well, Janus Pro 7B, that bigger model, scored 79.2 on Bench, which is not only better than the original Janus, but it even beat out other state-of-the-art models, like some much bigger models like TokenFlow and Metamorph.
So better performance, but with a smaller model? That's impressive. But we can't forget the other side of things. How about text-to-image generation? Did it do well there too?
This is where things get really interesting. So they tested Janus Pro on two main benchmarks. GenEval and DPG Bench. GenEval is all about, how well the model can create images with lots of objects, and those objects have complex relationships between them. DPG Bench, that stands for Dense Passage to Image Generation Benchmark, that one tests how well the model can actually follow instructions and generate an image that matches what you told it to do.
So not just pretty pictures, but pictures that make sense based on what you asked for? Did it do well?
It aced both tests. GenEval, it scored 0.80, which is better than even DALI 3 and Stable Diffusion 3 Medium, which are both pretty amazing models. And on DPG Bench, it got a score of 84.19. Again, top of the class. This means Janus-Pro is really good at following instructions and, actually making the image you ask for.
Okay, that's pretty amazing. Sounds like this decoupled visual encoding idea is working. But no model is perfect, right? There's got to be some downsides, some areas for improvement. What are some of the limitations they found with Janus-Pro?
You're absolutely right. No model to perfect, there's always room to grow. One thing they found was that the input resolution for the understanding side is limited to 384 by 384 pixels. Now, that might not seem like a big deal, but for tasks where you need super fine detail, like, say, trying to read text in an image, that could be a problem.
So it's not that it can't understand the text, it's just that it can't see it clearly enough if it's too small or too crowded together. What about the other limitation?
On the generation side, the output resolution is also limited to 384 by 384 pixels. So the images are good quality, but they might not be as sharp in detail as some other models can create. And there's a technical thing with the VQ tokenizer they use. It can sometimes lead to a loss of those fine details in the image.
So the big picture's clear, but those tiny details, maybe not so much. Makes sense. Even with those limitations, though, the things Janus-Pro can do are pretty incredible. Seems like we might be seeing a real shift in AI with this kind of performance. Now, before we wrap up this part of our deep dive,
Earlier you mentioned the team behind Janus-Pro. They did some specific things like tweaks to the training to make it more efficient. I bet our listeners would love to hear more about that, how those small changes can actually make such a big difference.
definitely, it really shows how much those details matter in AI. Remember that three-stage training process we were talking about? Well, in the second stage, the unified pre-training, they made a change that really boosted the model's performance.
Right, they decided to just get rid of the ImageNet data completely in that second stage. That's pretty bold considering ImageNet is like used everywhere in AI training. Why'd they do that?
Well, see, in the original Janus, they used ImageNet in that second stage to train the model to generate images from like just category names, dog or car, things like that. It was supposed to help it learn those basic visual features. But they realized because of that longer training on ImageNet in the first stage, the model already kind of had those basic concepts down.
Ah, so by dropping ImageNet from the second stage, they could streamline things and focus on training it to generate images from those richer, more detailed descriptions.
Yeah, exactly. And not only did that improve the quality of the images, but it also made the training go much faster, more efficient. It's all about like using the right data at the right time.
And while we're talking about optimizing the data, we can't forget about that synthetic data they used, right? Especially for image generation. That was a big part of why Janus-Pro is so good.
Totally. And it wasn't just any synthetic data. It was synthetic aesthetic data, meaning they were training it to create images that weren't just realistic, but also looked good. It's like teaching an AI to have good taste, an eye for art.
And it worked. The model learned much quicker using that synthetic data, and the images it made were more stable, less errors, and they looked better too than if they had just trained it on real photos alone.
So they're basically taking advantage of that synthetic data to like boost the model's ability to create, aesthetically pleasing images. Clever. Now, let's talk a little bit more about those benchmarks they use to test Janus-Pro. We mentioned them before, but I think it'd be good for our listeners to really understand, what they measure and why they're so important when you're evaluating these AI models.
Good idea. Let's start with Bench, the one for multimodal understanding. We know it tests how well a model can understand text and images together, but what does that actually look like?
Yeah, what kinds of tasks does it do?
So it's actually a whole bunch of different tasks, all mixed together. It includes things like image captioning, where the model has to write a description of what's happening in an image, or visual question answering, where it has to answer questions about the image. Some of the tasks even involve figuring out the relationships between the objects in the picture, how they interact with each other.
So it's a pretty thorough test of how well the model can connect what it sees with what it reads. And if I remember right, Janus-Pro did really well on this one, even beating out some bigger, more complex models.
It did. Its performance on Bench shows that it's really capable of that deeper contextual understanding, connecting the dots between those two different types of information, visual and language. which is, super important if we want to develop more advanced AR systems.
Now, let's move on to those text-to-image generation benchmarks, Geni-Al and DPG Bench. What makes them so relevant, especially for a model like Janus-Pro?
Well, Geni-All focuses on what we call compositional abilities. Basically, it tests how well the model can create images that have multiple objects in them, and those objects have to be arranged in a way that makes sense. It's not just about creating a pretty picture, it's about creating a picture that actually tells a story, conveys a meaning.
And DPG Bench is all about following instructions, right? Which is like super important if you want AI that can actually interact with humans in the real world. You need it to be able to understand what you're asking for.
Right on. And Janus-Pro did great on both of those benchmarks, both Genevol and DPG Bench. It proves that it can take those complex instructions and actually turn them into images that match what you asked for. It's not just understanding the words, it's understanding the intent behind them.
So it's not just about being good at understanding images or text separately. It's about being able to weave those two things together, seamlessly. That's where Janus-Pro really shines. It shows how much potential this model has, especially for those tasks that need a deep understanding of both visual and textual information.
And that leads us to another important point, the scalability of Janus-Pro. Remember, they developed two versions of the model, one with 1 billion parameters and one with 7 billion. The fact that they were able to scale it up like that shows just how robust their approach is. And it opens up a lot of possibilities for the future, even bigger and better models down the road.
It's almost like having different sizes of the same tool, right? You pick the one that's right for the job. And in AI, that kind of flexibility is incredibly valuable, especially with how fast things are changing in this field.
Absolutely. It lets develop.
Oh, wait, someone wants to join. Hey, go for it.
Hey, so what's the difference between generation and understanding?
Oh, great question. Okay, let's unpack this. When we talk about understanding in AI, especially with images, it's like the model is trying to, make sense of what it's seeing. Like it's trying to recognize objects, understand what's happening in the scene.
Exactly. It's like if I show you a picture of a dog playing in a park, the AI needs to understand that there's a dog, that the dog is in a park, and it's playing, right? It's got to build a mental picture of the scene, and that's understanding.
Right. It's taking those raw pixels and turning them into like meaningful information that it can use. And that understanding is what allows it to answer questions about the image.
Now, generation's a bit different. It's like the model is taking information, text, or even another image, and it's actually creating something new. It's making a brand new picture based on what it's been given.
So it's not just recognizing the dog in the park. It's like if I say, draw me a picture of a dog playing in a park, it can actually make that image from scratch.
Exactly. It's like being an artist that can paint a picture from words, understanding, it's figuring out what's there, the generation, it's creating something new. And Janus Proer is really good at both.
Yeah, and that's why they decoupled the visual encoding. They realized that understanding and generating are very different tasks and shouldn't use the same encoding.
That's right. And we were just getting into the limitations of Janus Pro, which are really important to keep in mind. So, for instance, there's the input resolution for understanding, which is limited to 384 by 384 pixels.
Now, what about that second limitation, the output resolution for text-to-image generation? Also capped at 384 by 384 pixels. That might be okay for some things, but in fields where you need really high-quality, sharp images, it could be a drawback.
Yeah, think about like graphic design or advertising. They need those super high resolution images. Or in architecture or engineering.
Ah, yeah, uh-huh.
But encoder have the same architecture. Did did they?
That's a really insightful question. It's clear you're thinking about the fine details of the architecture.
Yeah, it's a great point. So when we talk about the encoders, remember there are two, one for understanding and one for generating.
And to clarify, they don't have the same agriculture. I believe you meant architecture.
Yeah, that's it. They're not identical. They're specifically designed for different tasks.
The understanding encoder, that's the SIGLIP encoder we talked about, it is designed to extract those semantic features from images, the meaning behind it all.
And the generation encoder, the VQ tokenizer, that one's focused on turning images into a language the model can actually use to create new pictures.
So they are built differently to optimize for their specific jobs, which is at the heart of Janus Pro's design, but both output to that shared autoregressive transformer.
Exactly. They might have different goals and different structures, but they both work together, feeding into the unified transformer to achieve the overall performance.
And that's what makes it so efficient and why it's able to do both understanding and generation so well. Now, where were we?
We were just talking about the limitation of the output resolution being capped at 384 by 384 pixels.
That's right. It means the images are good quality, but they might not be as sharp and detailed as some other models can create.
Totally. Janus-Pro is a big step forward, no doubt. But there's always room for improvement, always more to learn. Oh, back to our listener. What's up?
Thank you for explanation.
You're very welcome. I'm glad we could clarify things for you.
Yeah, it's always great when we know we're making things easier to understand.
Well, where were we? Ah, yes, talking about those limitations of Janus-Pro.
That's right. Even with all of its successes, there's still room to grow.
And think